And when I talk about NLP, I'm mainly going to be talking about one technique that is advanced research application. I'm probably mispronouncing this, so I'm just going to call it LTA from now on, so it's painful for everyone. And I will be demonstrating to you how everything is performed with Python, but I'm not going to focus too much on the code of the details of the code, just because I believe there are amazing tutorials and talks out there that help you understand cleaning the data, preparing the data, running the models. So I'm not going to do this today, but I'm basically going to talk to you about the motivation and decisions that I have to make through the way and how to interpret the results and how I want. So a little bit about who I am. This is a nice version. So my name is Nick. I am a final year PhD student at Cardiff University in the Department of Mathematics. I study something called game theory. My research in general heavily relies on software, so I develop my own software. I consider myself a research software developer, and in my first year, I was awarded a fellowship from the Software Disabilities. I'm also an editor of Plus Channels, Plus Channels website, and I am the editor of the Open Source Toolkit. And alongside my co-editor, what we're trying to do is promote academic articles that the code that accompanies them has been written in a sustainable way, in a reproducible way, and is available for people to use. It is under the Plus umbrella, but we do try to advertise other papers and published in other journals as well. I am an active member of the Python community. What that means, I do attend PyData Cardiff quite regularly, giving talks to many Python conferences, including in the UK and international ones. I also help organize Java workshop. I've been doing this for the past 3 years. We do have actually an attendant from our last event here today. So there are a lot of things going on in Python that you can always be involved in. So this is who I am, and like I said, I'm now a fourth year PhD student, but when I started, I was a newbie. I was a first year PhD student. And in my first year, I came across this. And what is this? It's the graphical guide to doing a PhD. And I'm going to talk about this because this is the motivation of this talk. So actually, my purpose, and just to summarize what it said was, okay, the knowledge of the entire world is within the outer white circle. So the white circle is actually the bounds of the human knowledge. So the way that we learn as individuals, we're in primary school, middle school, we have middle schools, is that our knowledge expands in a circular way. So being taught in several different subjects, the sciences, languages, etc., etc. And even if we go to high school, so this is our house, this is us in high school. So now education is a bit of a higher level, but we still our knowledge is expanding in that circular way. But what happens when we start around the graduate degree? This is actually when we start. I thought I could reach that. So this is when we start deviating towards a specific point now. And then if we do a master's degree, then we deviate even further, closer to the bounds of the human numbers. And how do we get from that point to the end? That is what a PhD is all about. And though if we could zoom in in the point of the arrow, what Matt very nicely summarizes, the aim of a PhD is to get to the bounds and just push it a bit further. But how do we know what the bounds are? So in academia, what we do to understand what the bounds are, so in order for us to push it further, is to do something that is called the literature review. So we have to go and we have to understand what other people before us have done, what methods they have used, what results they have published. And the way to do this is to read academic papers. So for example, academic articles which live on the web. So for example, if I was looking for an academic paper that had something about game theory and rhinos, I would open my web browser and Google. I would type rhino game theory, press enter, and click the first link that came up. And here's an example of our response that we get. Okay, so this is actually the website of a journal. The journal is called Science Direct, fantastic. And there is information associated with the article. There is a title, an evolutionary game theory model of final point evaluation. Fantastic. My search was successful because game theory and rhino is there. There are other information. There is the name of the authors. I'm one of them. And then there's other information associated, like the volume, when it was published, the abstract. Now, there's not only one journal. There's not just Science Direct. There are actually multiple journals. And specifically, my domain, 4 very prominent journals and a preprint server are these. So Nature, PLOS, IEEE, and Springer are journals, and now Archive is a preprint server. What is a preprint server? Is somewhere we upload academics, researchers upload the papers before they're being published, so they are available because publications, the whole process can take some time. So what all of these journals do have websites that we can go and again go on Google, search, click. But they also allow you to smarter and faster way actually retrieve information from them. And that is by using something that's called an API, which is a communication protocol. So what you can do with an API is talk to the database, and the database will return you the results. And you can do this, you don't have to collect one article at a time, you can actually collect multiple. So for example, if I wanted to collect articles from Nature, the detective is me, what I would do is I would send a query, I would send a message to the API, I'll be, oh, I want this, and then the API will return me a response. The format of the response could be XML, computation, the different formats, and I'm getting my results quite fast. Now, the one issue is that if I wanted to repeat the process for the other journals, for the other APIs, then I would have to go and speak the language of each API itself, because both the query and the answer is different. And I actually came across this problem when I was first with this issue. And I was like, okay, I want to collect a lot of articles, I'm going to do this, and this happens. And I was like, okay, but I don't really want to talk to 6 different APIs each time. So what I did is I built a Python library. So that's what you do as a first student. And its name is Arcus. And what Arcus does is a translator. So me, I can only have to speak to Arcus, and Arcus will translate my message to each API, and it will return me, it will give me my results. An example of how we use Arcus, I'm going to be writing some code in a Jupyter notebook. Can you see this? Yeah, fantastic. So in the first line, I'm just importing Arcus, and what I want to say is, okay, I want to talk to the API of plus. So I'm just going to create an instance of a class named plus, and you see what I'm saying is, okay, I want an article where in the title the word game is there, and in the abstract the word game is there. And I also want one record. I don't want many, I want one. So by doing this, I am creating a URL, and actually what the URL is a query. So run this. This is the message that the Close API understands. Right? My message and the address, everything is there. So what is returned now? So I'm scraping, I'm removing all the the XML and all and everything. But if we look at the information that is being returned by the API, this is what we get, right? So we get author display, we get the abstract, we get the information about the paper. If I wanted to repeat the process for another journal, what I have to do now is just have to go and specify a different one. I want to speak to Nature now. So I'm going to repeat the process, but I'm just saying now I'm using a different API. And you will see. We see the message now. Straight away, this message becomes longer. It becomes more complicated than the plus one was. Right? So this is why I don't have to do manually. This is what Arcus does for me. And then if we look at the results that we're getting from Nature now, regarding the article, we will see that also the keys now of the response are different. For example, instead of having abstract, I don't know if you can see it, says again, the message, the query is different, and the answer is different. What this allows you to do is to actually standardize the replies. And actually standardize them into a pandas data frame. So now, no matter from which API is coming, the columns are all the same. Some APIs, some journals have other information, some information that others don't. If that happens, then Arcus is just going to say, oh, the information is not available. So this code there is not available. But everything is being standardized. So this is what Arcus does. And Arcus is quick installable. I am the main contributor. It is quick installable. It is available online. I'll be sharing the links and everything with you. So what can we do with Arcus? So what the API allows us to do is collect multiple articles instead of one at a time. And what Arcus allows us to do is collect multiple articles from multiple journals at a time. And what we can do with the data, there are actually various things that we can do. I actually wrote a blog post in 2019 of how we can use data to check if all women publications exist in mathematics. And there are other blog posts as well. Use Arcus, and I'll be sharing the links at the end of the talk. But let's go back to my PhD. Now I have this tool, and I'm like, okay, how can it help me? How can it help my research? How can I get a chapter out of this? So my research specifically is on something that's called the prisoner's dilemma. It's a game on game theory. And actually, my supervisor in the last meetup, he gave an introduction and a talk about the type of research that we do. So, prisoner's dilemma is the magic word. And I was like, okay, can I get articles on the prisoner's dilemma? And I can, actually. And all I have to do is I'm going to do a search. And I'm going to show bring me all the articles, somewhere in the title or in the abstract, the word prisoner's dilemma exists. And what I'm getting is the first article happened. The first article that I retrieved was in 1950. The last one was somewhere in 2018, because that was the last time I ran the collection process. And what you see is the cumulative sum. So in the end, in 2018, I have up to 2,500 articles. So now that's a lot of data. It's a lot of information. I was like, okay, now we have to analyze it, and we need something out of this. And one might say, well, you can create a machine to write your literature review for you. But I did not do that. But I was like, okay, how can you help me? How can you help me understand my field a bit better? So the question that I will be answering is, why do people write when they write about the prisoner's dilemma? When people publish, what are the topics that they're discussing about? And in order to do this, I'm going to be using natural language processing, and more specifically, LDA. And what LDA is a topic modeling technique. So you will give it a list of documents, and you will try to identify hidden topics that exist in these documents. And what do we mean by topics? Topics are just describe a dominant words, other specific words that people write about. In one, it's a few papers, and other words that they write nothing. So back in the notebook. Again, here I'm just importing a few libraries. I have created a script with some useful functions for what we're doing, which is all done with the scripted LDA tools. I'm not going to go into the details of the functions, but again, everything is available online if you would like to have a look. This is what my data looks like. So I'm just reading in my CSV, and you can see the path as data frame. It has the abstract, author, the degree, etc., etc. Now, in order to perform topic modeling, I need to choose the information I'm going to fit into the machine. And what I have chosen is the abstract, because I believe the abstract of the titles of the articles has enough information about what the article is about. So the text I'm going to be using is just a list of all the abstracts. And if you can see, okay, if I look at the first abstract, we can see that the words are starting from the widely accepted prisoner's dilemma. So I've taken the sentence and I've broken it down to words, and I've also lowercase everything. But we need to clean them more. So the lemmatized text is what we'll be using. And then what I'm doing is I'm just cleaning the words. I'm removing the stop words, I'm removing things like from, the, I'm removing the slash N that was left in there. And also if you see, if you see here the word was starting, now it starts. So we're taking the roots of the word. We don't take accepted, we take accept. And in order to run the LPA model, I'm using a library that's called Gensim. And Gensim, actually, the only two things that I need to define, the only two things that I need to define for the LPA method is a dictionary. So it's the words associated with an ID, numbers, and then is a corpus. So what a corpus is a mapping of key and frequent. So if you look at the corpus, what we're seeing again is the abstract of the first article, right? And if we remember, the word start was there. So starting now with 0, the ID of the word start is 0, and how many times does it happen in the first abstract? 1. And exactly. So these are the two things that I need to go into the model. And here, in a few lines of code, we're just running the model. We're specifying the corpus, fantastic, I'm specifying the dictionary. I'm specifying the random state so I can reproduce my results. And here I have to specify the number of topics. So how many topics do I want LDA to figure out And this is not something that the LDA chooses for me. It's something that I have to manually specify before running the method. And this is the type of result that we're getting. So let's go back so we can look at the result in a better format. So LDA said, okay, fantastic. You asked me for 2 topics. Here are your 2 topics. And these are the words that represent 2 topics. So for example, for topic 1, we're getting agent, network, strategy, and social are the words associated with the topic. And how much they contribute, what is the weight? Well, social has a weight of 0.01. And then equivalently for topic 2, that's what we get. So what is a topic? A topic actually is a distribution of a words. We can see here that the words are quite similar. In some cases, they even have the same weights. Sometimes they have different weights, and sometimes the words are contributed towards one topic and not towards the other. Fantastic. Now I have my topics. What's the next thing that I do? Well, the next thing that you want to do is actually finding which topic your documents go to. What do I mean go to? So let's say we had an article, and the abstract is the social network of agents. I came up with that. So what we need to find is how much each topic contributes to this abstract. So for example, one is going to have, it has word social, which is, what was your, no, it's agent, sorry. So it has agent, fantastic, so it's going to have 0.09. In topic 2, agents had a weight of 0.02, 0.08, and then network is here, social is here, and then also here is network, and it's fantastic. So actually what we're doing is that we're taking a topic, we're taking an abstract, we're taking one article, and we're describing it as a vector of 2 topics. So now, actually, articles are just a distribution over topics. Topics are distribution over words, and abstracts are distribution over topics. To which topic we would assign this article? We would go to the one that explains our abstract more. So we would say, okay, this paper is actually going to be under topic 1. Is 2 topics is the number of topics to the right one? That is the other question that we have to answer, because I put 2 as an arbitrary number. So we need to choose the number of topics. So that was one of the things that I have to specify. And in order to do that, I use something called the coherence score. It is implemented in Python. So like it was like, okay, I'm going to run my model, and I'm going to run my model with different values of the number of topics. For my research, I did this from 2 to 20. Here's an example. I'm taking it for 2 weights. The coherence score is the y-axis, and what we can see is a positive value is a good coherence score. What the coherence score measures is actually the similarity of the top words in each topic. So what you're seeing here is the average similarity, and a positive number is a good number. So what this is telling me is the 6 is the right number I should choose. So now just trusting one measure is not always enough. And actually what we did then, what I did is I manually looked at the topics, I looked if they made sense, and then I looked if there was actually any overlapping of the words between one topic and the other. So we do some further examination, and actually I will tell you that no, 6 was not the right number of topics for me, for a data set, it was actually 5. So for my work, I chose 5. And so trusting just one measure, it gives us an indication, but then doing some further examination is always good. So just to summarize what we have done so far. What we have done so far is we took a bunch of documents, and another document is a bunch of words, so it's one document is a bunch of words, so it's a high dimensions. And what we did is using LDA, we say, okay, actually, one paper can be described by a vector of 5 numbers, right? Because the distribution over the topics. And then what we said is like, okay, from these points, we are actually going to choose the one that is more likely to be there, or we're going to choose a category for each paper. Now, this is still a 5 dimensions, so what I'm going to show you next is what happens if we reduce it, just to visualize it, and this is actually what happens. So what you're seeing with the color is the topics, and each dot is the documents. So these are all the same topic, these are all the same topics, and we do get some overlap, but remember that this went from 5 dimensions to 2 dimensions, so there is some information missing there, so we don't know why this is happening. But we chose 5, we get nice visualization out of this, but what is the real result? What are the topics of the prisoner's dilemma? Why do people write about it? And this is how the topics, these are the more dominant words in each topic. Now, if you're not familiar with the prisoner's dilemma, this is not going to make sense to you. If you're familiar with the prisoner's dilemma, this will still not make sense to you. So what I had to do is like, okay, I looked at the words, and there were actually some topics that I can easily identify and say, yes, I know this. For example, this, population evolutionary. I knew that these are articles where people write about evolutionary dynamics in the prisoner's dilemma using them. Fantastic. There was this, social behavior study experiment. Okay, what is this about? Okay, the prisoner's dilemma a lot of times is played with humans, so we conduct experiments, we conduct social experiments, if people are going to trust each other or not. This, game strategy player agent. I was like, okay, this took a little bit more time, so what I had to do is look at the documents that have been assigned to the topic, read a little bit about the abstract, a little bit about the paper, and what this is actually doing is using computers, using agent-based models to play with it. There were 2 topics that were a bit harder again to figure out, individual, group, good, high. What this is actually is papers written on the applications of the prisoner's dilemma in biology, so like modeling viruses and bacteria and animals. and here model theory, system, and problem. So these are actually papers that write about using the business dilemma to model other real life problems. So for example, OR or finance, etc., etc. So what is the results from the four journals that I have used and the preprint server? What do people write about? They write about these 5 topics. They talk about evolutionary dynamics, they talk about people, they talk about computers being used to play the game, they talk about the applications of the game on biology and in other fields. So if I ever told you that I studied the business dilemma, you ask me, do people still write about this? I'll tell you yes, actually. And based on 5 journals, the topics that people talk about. There are also other type of research, other type of methods that we can apply to the data sets. And even with topic modeling, then we can see how things change over time and how topics become less or more important. But the other thing that I would like to touch upon is, okay, now I know what people write on. I would also like to know how people go about writing. So, is a business dilemma a collaborative field? So in my data set, apart from the abstract that I've already used today, there are other information as well. And one information with the name of authors. So what I can do actually with the authors is create this. And when you're seeing this is a call to significance. So for example, I am a note somewhere here because I've written a paper on the business dilemma. The people that have written with me, we have a line. So if we have written together, there's a line connecting us. But if I've also written with you, I have another line connecting us as well. And there's a lot of things that we can get out of this because we know network theory and graph theory. In mathematics, we have a lot of measures that we can throw at it. And there's a lot of interpretation, a lot of information that we can get out of it. But I'm only going to talk about one measure today, which is the degree measure. So the degree is, on average, if I only write in the business dilemma, if my only publications are here, and the people that I write with are here, on average, how many people are we connected to? And the answer is 3. So if my mom is worried that I work all the time and don't have a social life, I can tell her 1. I'm connected to at least, on average, I'm connected to 3 people. It's good. How does this compare to other fields? I did collect some data in other game theory subfields, and I see 3, they did have an average degree of 3 as well. So if I have to answer the question to my point, is business dilemma a collaborative field? I will tell her, well, it is, right? So you are at least connected to someone, you're not alone, but we're not necessarily more collaborative than other fields. There's a lot of more things that we can do with also natural language processing and with the co-authorship network that I did not touch upon today. But this has led into a manuscript, which is currently on print. This is my co-author, Mr. Nice. He's also my PhD supervisor. So if you would like to learn more about it, please go online. If you have any comments, I would appreciate them. This is the information. This is my co-author's information. The slide will be online. The paper is here. And these are also the 2 blog posts on using art as to do other things apart from having the business dilemma. That was me. Thank you very much for listening to me. Thank you.